doing? This is E.L.V.A once again. I hope you are doing really good today. So today we are going to be looking at ABGs interpretations. We're going to look at how to interpret our acid-base imbalances and to figure out what kind of compensation is going on. There are a couple values that we need to keep in mind. So there will be our pH, also our PaCO2, and our HCO3. So your pH refers to the acid-base imbalance of your body. So it's measuring the level of acid and bases in your blood. So keeping your body at homeostasis, okay? And the normal value for that is 7.35 to 7.45. All right, so that's our normal range for our pH. And then we have our PaCO2, which is basically measuring the carbon dioxide. So PaCO2, so CO2 is our carbon dioxide level, and the Pa in front of it is basically measuring the partial pressure of the carbon dioxide in your arterial blood. So partial pressure of the carbon dioxide in your arterial blood. And the number value for that is 35 to 45. All right, one of the ways you can easily remember your PaCO2 number value is if you notice with our pH, we have 7.35 to 7.45. So if you just remove the 7 point in front of it and the 7 point in front of 45, you would remember what your PaCO2 is, which is 35 to 45. Okay, and our final value that helps us to calculate our acid-base imbalance is our HCO3. And this is your bicarbonate, okay? That is what measures the base in your body. So your PaCO2 kind of deals more with the acid because carbon dioxide is acidic in nature, while your HCO3, which is your bicarbonate, is basic in nature, which is alkaline in nature. So HCO3 normal value is 22 to 26, okay? You just got to remember that number. All right, so now knowing this, we have to figure out when it is high versus when it is low, what kind of issue is going on. All right, so with our pH, which is our acid-base balance of the body, with your pH, when your pH is less than 7.35, we say that it is acidic. All right, so acidosis. We have a situation of acidosis. And when it is greater than 7.45, we have a basic situation also known as alkalosis. All right. With your PaCO2, it's opposite. So your carbon dioxide goes in the opposite direction. When you actually have something less than 35, I'm going to use another color so we kind of see it clearly. So anything less than 35, we say it is actually alkalosis, and it makes total sense. Because remember, your carbon dioxide is acidic. So if it's less than 35, it makes sense that it is basic, so alkaline. And if it's greater than 45, the more acidic it is, so acidosis. And then finally, we have our HCO3, which is your bicarbonate. So your bicarbonate HCO3, if it's less than 22, it goes in the same direction as your pH, which is acidosis. And if it's greater than 26, it is alkalosis. All right. So another factor you want to keep in mind is that, remember, your pH is telling you about your what's it called? Your acid-base imbalance. So it is our primary factor, okay? But your PaCO2 over here actually represents your respiratory, and your HCO3 represents your metabolic, so your kidneys. All right, your respiratory represents your lungs. Okay, so it is important to keep that in mind as we do some of our, examples that we're gonna do soon. So this is very important. Knowing these normal values, your pH is 7.35 to 7.45, and your PaCO2 is 35 to 35 to 45, and your ACO3 is 22 to 26. Before we go forward, it is very important to know that right here in the middle, like this middle point between 7.35 to 7.45, we have a number there. All right, and our magic number is 7.40. All right, we need to keep this in mind. It's kind of like the very middle and pinpoint of all where our pH breaks into those two extremes. Okay, so with that in mind, now we can start to do some questions and practices. All right, we're gonna use what I call the tic-tac-toe method. It makes this a bit more easier to do. All right, here is our first question. So our first question says that our pH, you have a patient with a pH of pH is equal to 7.51, and you have a PaCO2 that is equal to 49, and let's say we have a ACO3 that is equal to 40. All right, so just to put it out there, guys, so there are some questions that we give you maybe a piece PaO2. They might give you a PaO2 value like this. Keep in mind that you are actually not going to use your PaO2 to calculate your acid base imbalance. So that is just giving you, it's just letting you know what the partial pressure of the oxygen this time around in your arterial blood is. But we don't, that's not a factor that we'll really consider when we are trying to interpret our acid base imbalance. So if you have that in your question, some question might even go ahead to give you like a HSO2, so your oxygen saturation. Again, if you see these two, you don't necessarily need it. So just put them away. All right, it's there for extra information. They're trying to let you know the partial pressure of oxygen, and they're also trying to let you know the saturation of oxygen in your blood, but we're not going to use them in our actual interpretation to figure out what kind of imbalance is going on. You only need your pH, you need your CO2, and you need your bicarbonate. All right, so knowing these values that we have, we're going to use the tic-tac-toe method. So I'm basically going to draw that. All right, I'm going to put my pH in the middle because it's kind of like my primary buffer. It's my main determinant. So I'm going to keep that in the middle, and I'm going to write my PaCO2 on this side and write my HCO3 on this other side. All right. So now I'm going to look at my value, go back to my value. I have a pH of 7.51, a pH of 7.51. That is alkalosis, okay? It is greater than 7.45. All right. So we're going to come down here and write down what our pH is, which is alkalosis. Okay, our PaCO2 of 49 is what? Is acidosis. All right, it is greater than 45. All right, by the way, I am comparing, think of this like my key that I am using to solve my questions right now. All right, this is like my reference point. Okay, so my PaCO2 of 49 is acidosis. So go right and hit right acidosis. And my HCO3 of 40, going back to my reference point, 26 is greater than 26, so it is alkalosis. All right, so it is alkalosis. So when you do this, now what you gotta go do is go back to your pH. So ask yourself, my pH is alkalosis. Which of these two, with this one and this one over here, which of them matches my pH? All right, I have a pH which is alkalosis, and the one that is matching it right now is my HCO3 over here. Okay, so and that is, remember, your HCO3 represents your metabolic, which is your kidney. So it is my metabolic, which is my bicarbonate, that is matching my pH. So this tells me that this is a metabolic alkalosis situation. All right, it's a metabolic alkalosis, and that is basically how you solve this. My PaCO2 over here is trying to compensate. All right, it's saying that, hey, we have a problem, because that's what your ABG literally is. They are always trying to compensate when the body, right now, the body is extremely basic. Okay, alkalosis is going on, so this patient is probably vomiting, or they're having they have some nasal tube suctioning going on, so they are losing a lot of acid. That's why the body is going into this basic alkalotic state. So our PaCO2, which is our kidney over here, respiratory, is trying its best to compensate, to pull the body back to an acidotic state. So you can see it's moving from its normal range to the acidotic side, but we still don't have a complete compensation. So we're going to talk about compensation later on, but I want us to do a couple more examples of this. All right. So I hope you understand this. We're going to do a few more examples, and then I'm going to talk to you about how to figure out what kind of compensation do we have going on. Another example that we have a pH of 7.29. A pH of 7.29. Again, going back to your reference point, 7.29 is less than 7.35. So it is what? It is acidosis. So guys, I want you to literally do this with me as we do it, so that way you really understand it. Okay, so PaCO2 on the other hand is 53. Going back to our reference point on this left side of the screen, it's greater than 45, so that would be acidosis. So respiratory would be acidosis. So the HCO3 on the other end is 22. So looking at our reference point, 22 to 26 is actually normal. So our HCO3 is normal. All right. So we're going to write normal over here. So now once again, remember, you gotta now look at your pH. Which one of them matches my pH? My pH is acidosis. Of these two, which one matches it? Which would be the PaCO2, which is your respiratory. So this situation, this acid-base imbalance, is a respiratory acidosis situation. Y'all don't mind my handwriting. Pardon me. All right. So this is another example for us. All right, we're gonna do a couple more still before we talk about the kind of compensations that we have. All right. So guys, if we have another example, pH of 7.35, PaCO2 of 25, and HCO3 of 18. So once again, our pH is 7.35. If we go to our reference, pH of 7.35, is it normal, is it acidotic, or is it alkalotic? It's normal actually, okay, because it falls within that range of 7.35 to 7.45. All right, so we actually have a normal pH. However, does it lean more towards our acidotic side or our alkalotic? Remember guys, I told you we have this 7.40 here, which is kind of like our middle point. Okay, 7.37 is below that, so it's normal but tilting more towards our acidotic side. Okay, so we need to keep that in mind, because it will help us to figure out what imbalance is going on. Then our PaCO2 is 25. So going back to our reference point, 25, that means it is alkalotic because it is less than 35. and our HCO3 of 18 is less than 22, which makes it acidosis. All right, so with this in mind, going back to your pH to be your reference point, although I have a normal pH, we established that it leans more towards the acidotic side, so it matches with my HCO3. So therefore, I have a metabolic acidosis situation on my hands. All right. And guys, that's all the examples I want to give you on how to interpret your ABGs. Now, let's get into the compensation. Let's ask ourselves, what kind of compensation is going on? Do we have a full compensation, partial compensation, or do we have an uncompensated situation? So a couple of rules to keep in mind when trying to figure it out. Very simple, actually. So again, on my left side, I'm going to write out the compensation rules for you. So to figure out what kind of compensation, if we have a full compensation, a full compensation is when your pH is normal. All right. Whenever I have a normal pH, I have a full compensation because it means that, remember, your pH is the acid-base balance of your body. So whenever pH goes back to normal, that means this situation has been fully compensated. We are back to a good ground. Okay, so a perfect example of it would be this example that we just did on this side. So remember, our pH is actually normal. So this is actually a metabolic acidosis fully compensated. All right, it's a fully compensated metabolic acidosis because why? My pH is beautifully normal. All right, so that's our first kind of compensation. The other kind of compensation that we have is the partial compensation. So we say that a acid-base imbalance is partially compensated when all are abnormal. All right, when they are all abnormal and out of their normal range, we have a partial compensation going on because they are all trying to do something. They are all trying to solve the situation and solve the problem. So I will give you a visual representation of what that might look like. So if I have the situation whereby my pH, if my pH were to be acidosis also over here, all right, again, it's matching up with my HCO3, so I still have a metabolic acidosis going on, but I actually have a partial compensation. So I told you when they are all abnormal, you have a partial compensation. PaCO2 right now is alkalotic. It's not within its normal range. pH right now is acidosis. It's not within its normal range. HCO3 right now is acidotic. It's not within its normal range. So when they are all like this, right now PaCO2 is trying to help to fix the situation of acidosis going on. So it became alkalotic. So they're still trying to do something. So because of that, we say we have a partial compensation. Everybody is doing something. Hopefully soon we arrive at full compensation. But for now, we have a partial compensation going on because everyone, all our buffers, our kidney, our lung, the blood, they are all moving around trying to salvage the situation. So that is a partial compensation. All right. And then the final kind of compensation that we have is the really bad one, which is uncompensated. It's uncompensated because someone is not being nice. All right. And that happens when either my PaCO2 or HCO3 stays normal. So whenever I have PaCO2 or HCO3 stay normal, they are not trying to help the situation. And of course, my pH most likely is abnormal. We say we have an uncompensated situation. So a classic example of that would look something like this. So if I were to have a situation whereby my PaCO2, instead of being alkalotic on this side, it's actually normal. So if I were to have had a normal PaCO2, Yes, I still have a metabolic acidosis because my pH matches my HCO3. So yes, I still have a metabolic acidosis, but because my PaCO2 was like, you know what, guys, I don't care about y'all. I don't care about the acidosis that's going on. I'm not going to move an inch. I'm going to stay within a normal range of 35 to 45. I don't care. I'm not going to try to move around to go to my alkalotic side so I can try to balance y'all out. I'm going to stay normal. Because of that, we say that this is an uncompensated situation. All right, so it is metabolic acidosis uncompensated. We don't have a compensation going on here because our PaCO2 is just being unfriendly and it's not been nice. Okay, the same thing would happen if the reverse were the case. If my PaCO2 over here was is the one which is acidosis instead. So if I had a acidosis PaCO2 and I had a normal ACO3, this time around um my pH is matching up with my PaCO2. Okay, so I have a what? I have a respiratory acidosis. And I have what kind of compensation? Uncompensation. Because again, my HCO3 is the one this time around saying, I don't care. I'm going to stay normal. I'm not going to move. I don't want to compensate for you guys. So we have an uncompensated situation. So once again, guys, whenever you have ACO3 or PaCO2 not getting out of their normal range to help our situation, we have an uncompensated situation. But whenever you have all three of them out of their normal range, trying to salvage the situation to take us back to homeostasis, we have a partial compensation. And the only time we have a full compensation is when our pH is normal. All right, so before we round up, we're going to do a few examples on that so that we can actually, put everything we've learned today all together. All right, so we have a pH of 7.46. A pH of 7.46, looking at our reference on this side, it tells me that it is alkalotic because it is very much, even if it's just by 0.01, but it is still greater than my 7.45. So it is alkalosis. And PaCO2 of 22 is less than 35, so it is also alkalosis. And HCO3 of 20 is less than 22, and it is acidosis. So remember, we ask ourselves, which one matches my pH? The one that is matching my beautiful pH right now is my PaCO2. They are both alkaloses in nature. So I do have a respiratory alkalosis situation. Remember, we have to figure out what kind of compensation do we have going on. As you can see, they are all abnormal. They are all outside of their normal range. Our HCO3 is trying to compensate, but yet our pH has not gone to a full compensation. It has not gone back to being normal. So for now, we just have a partial compensation going on. All right? So we have a respiratory acidosis, alkalosis, partially compensated. All right, another example, we have a pH of 7.51. A pH of 7.51 is what? It is alkalosis. We have an alkalosis situation. And a PaCO2 of 29 is also alkalosis. And the HCO3 of 24 is normal. All right. So what imbalance do we have going on? The one that matches my pH is my respiratory once again. So yes, I have another respiratory alkalosis situation. But what kind of compensation do I have going on? Because my HCO3 remained normal, it did not budge and try to help us to compensate, we have an uncompensated respiratory alkalosis. Our final example is we have a pH of 7.37, and that is actually normal. Okay, we have a normal pH, but once again, remember we have to find where does it lean more towards, because we need it to help us figure out what kind of imbalance we have going on. It leans more towards our acidosis side. All right, our magic middle number is that 7.40. Okay. And then we have PaCO2 of 30. Our PaCO2 of 30 will be alkalosis. And our HCO3 of 17 will be acidosis. All right, once again, to figure out what imbalance we have, we need to ask ourselves which one matches our pH. Even though our pH, once again, is fundamentally normal, it leans more towards the acidotic side, and that matches with my HCO3. So that means I have a metabolic acidosis situation. To figure out my my compensation, my pH is normal. So that means I have a full compensation. So I have a fully compensated metabolic acidosis. All right. And that will be it, y'all. This is basically fundamentally ways to interpret your ABG. You can use the tic-tac-toe method. It works pretty quick, and you do need to know your normal lab values for your pH, your PaCO2, your HCO3. You need to know when we have an acidosis versus an alkalosis, and you want to remember this quick rules for figuring out what compensation you have. Thank you so much for watching. Please make sure you subscribe, like, share, and if you have any other topics you want me to treat, make sure you leave that in the comment section below. Until next time, God bless you, and you got this. Bye.